Okay, I decided to do something a little different. So this video is just going to show you one problem from each type that you're going to see in your quiz. So you have extra problems that I gave you that you can practice so you can check these answers in Schoology. But I wanted to come up with a short video that goes over the types of problems you're going to see on this quiz. So the first section that you're going to see in your quiz is where I'm going to give you a true statement in exponential form. And you're going to just rewrite it as a log. So we learned that logs are exponents. So my base is an 8. So I just need to write log base 8 of 1 over 8 equals this exponent. Okay. And that's all you're doing. That's a true statement. You can check on your calculator. You can hit the math key, go to log base, and type in the log base 8 of 1/8. It will tell you -1. That's a fact. So then you'll have a section where then you're going in the other direction where I give you a true logarithmic statement and you're just going to write it in exponential form. So when you're seeing problems like this, you have to realize it's log base 343. You write 343 as your base. The power is 1/3. Remember, logs are exponents, so this 1/3 is the exponent. And the fact is, the cube root of 343 or 343 raised to 1/3, it's going to be a 7. Okay. You got to get that correct. Okay. You can't confuse it. You can't mix up the numbers. You can check on a calculator. Okay. The fact is, you're going to have another true statement. Okay. So that'll be 8 questions on your quiz. 4 like this, 4 like this. Okay. Now you're only going to have one problem where you're expanding and one problem where you're condensing. So I purposely made this one a little bit harder than what's on your quiz, but I need you to realize these should be pretty easy to do. So what you need to realize is if you see a division, you're going to use a minus sign. Okay, so I only have an x cubed and I have a y. So to expand this out, I'm going to take the log, and I'll show this intermediate step. Some of you will be able to skip this step, but I'm going to take the log base 9 of x cubed and I'm going to subtract. Okay, the reason I'm subtracting is it's a division problem. Okay, so we're going to subtract the log base 9 of y. Now, some of you would have skipped this and did this right away, but now I'm going to move this exponent to the front. So my final answer is 3 log base 9 of x minus log base 9 of y. Now, if y was raised to a power, I would have a number in front of this log. But in this case, it's just to the 1 power. So should be easy for you to expand. Okay. And like I said, I'll keep it relatively simple as we're learning these properties. And then condensing is just the reverse process. So if I gave you this, it would condense to this. So for this problem, I'm going to write it as a single log. Okay. The fact that I see a minus sign, I know it's going to be a division problem. But what's up top is going to be a z. So that's the first thing I see. And I don't see a power. So it's just a regular z. But then my x, that's being multiplied. So right next to the z, I'll put my x. But it's going to be raised to the 4th power. Okay, because I have a 4 in front. So that becomes the power. And then on the bottom, I need to put the y, and the y is being raised to the 5th power, and that's going to be in the denominator. And we're finished. Okay, so again, how you can practice this, cover this up, and see if you can expand this. Okay, log base 6 of z plus 4 log base 6 of x minus 5 log base 6 of y. You would get back to exactly this. Okay, so then you will have a section where nobody in here should get wrong because I'm allowing you to use a calculator. Okay, so we learned that the calculators can do logs. So this one's basically asking 6 needs to be raised to what power to be 65. It's going to be an ugly decimal. So we're going to round to 3 decimal places then. But I have to hit the math key. So I hit the math key. It's easier to scroll up and look for log base. So once we find that, it's a simple matter of putting in whatever the base is. In this case, it's a 6, and then your number. Okay. And the calculator will tell you the exact value that 6 needs to be raised to. So it's going to be 2.3, and then really it's going to be 30. Okay, because that 9 becomes really a 10, and that makes that a 3. So 2.330 would be rounded to 3 decimal places. But again, trust the calculator for that part, okay? And then you will see a problem, an application problem. And the moment you look at the rule, you should know instantly, are we increasing or decreasing? So again, I just changed numbers around. The fact that I see this and I see the base is less than 1, I know it's going to be a decay. Okay, we're losing people. So population, we start out with 173,000. As time goes on, it's going to decrease. Okay, so I know this is exponential decay. Okay, now since it's a 0.85, the percent, it's not 85% decrease, it's 1 minus 0.85. Okay, so it's 0.15, which is 15%. Okay, it's a 15% decrease. Okay, once we realize that, you're just going to go to your trusty calculator, go to the y equals screen, and type in the problem. So in this case, 173,000, and then times, my base is 0.85, so either put in parentheses or hit times, raised to the x. Okay, now I'm going to make sure my table starts at 0 and goes by ones, okay, because you don't need to go by 0.1s. And then I can see as time goes on, so this is the year 2000, just like on your practice. And then as time goes on, 2001, you can see how the population is decreasing. So then the question is, in what year will the population be 10,000 people? Well, it's really going to be between 2003 and 2004. So I'm going to put in 2003. Okay. So by 2004, you're well under the, did I look at that correctly? No, I didn't. Sorry. It's 10,000, not 100,000. So let me go. I have to go down even more. So you're going to go all the way down. I'm glad I looked at that a little bit closer. In 2017. Okay. So in 2017, I thought it was 100,000 because of my eyeballs. So it's going to be 2017. Okay, and then that's all. You just need to be close. Now, if you say 2018, I would prefer 2017 because again, it's going to be somewhere in between there. Between 17 and 18 is when it's going to hit exactly 10,000 people. Okay, and then finally, you just want to go to 22. Okay, for this problem, since I have 2022, I want to know how many people, and I don't know how accurate this is. A lot of people are moving out. We only have 4,844.7, or you can round to the nearest person. Okay, about that many people are still in the city. Okay, so again, just a regular application. Who knows, maybe we will be buying a house where it increases. So if the base is greater than 1, we will see that that number is going to increase by whatever is the difference between 1 and the base. Okay, and then if it's greater than 1, it would be a percent increase. Okay, so then number 10, you are going to be given this formula. They're all done the same way. Whatever amount of money we start with goes first. So we're taking $8,500 to the bank. We have 1 plus our interest rate as a decimal. So move this decimal point 2 places to the left, 0.0625, divide by n. And in this case, we read it is compounded monthly. So there are 12 months in a year. So I divide by 12. And then I raise to the n times t. So n is 12. The number of years is 15. So we're going to let that money sit in the bank for 15 years. And all I need to see is typing this into your calculator. So you're going to take your calculator. You're going to type in 8,500. You have 1 plus 0.0625. You'll divide by 12. and you'll raise it to the 12 times 15, okay? And as soon as you do that, you will need to just write down the answer to the nearest penny. So you would expect 77 cents, not 76 cents, because this is 5 or greater. Okay. So at the end of 15 years, your 8,500 really becomes $21,652.77. Not bad. Okay. And that's a pretty good interest rate. Okay. Then the last two problems I'm just reviewing. A lot of people are struggling with understanding how to get rid of exponents. Okay. So the first problem, we need to undo the exponent right away. I can't get to what's inside the parentheses, and there's nothing on the outside of the parentheses. Now, if there was a number on the outside, you're not allowed to distribute that. So if there was a number on the outside, like 3 parentheses, I'd have to divide by that number. But in this case, I am ready to get rid of the exponent right away. I raise to the 6/7. So I'm simply going to ask my calculator what 128 raised to the 6/7 is. And it tells me 64. I can drop the parentheses, and I have 72 minus 2a equals 64. And now it's a two-step equation. I'm going to take 64 minus 72. You're going to see that it is a -8. And I'm going to divide by -2. And I get a nice answer of 4. Okay. The next one, I need to get m all by itself. Okay. I cannot get rid of the exponent until I get rid of the 6. So 2m raised to the 5/3. This will be 6,250. Okay. Then I'm going to divide by 2. So 6,250 divided by 2 is going to be 3,125. And then my last move is to undo the exponent. We raise to its reciprocal. Okay. We don't divide by it. We raise to the 3/5. And I'll ask the calculator what 3,125 raised to the 3/5 is. And it's going to tell me 125. And that's my answer. Okay. And one way of quickly checking this, I can go back to the original equation and I can check to see if my answer actually works. So if I take 6 plus 2 times my answer of 125 raised to the 5/3, calculator will calculate in those PEMDAS. So it'll raise this, it'll multiply by 2, it'll add 6, and it better come out to 6,256. And it does. Okay, so that's one way of checking any equation. You can take your answer and substitute it back in to the original equation. So that's your quiz. Okay, you need to make sure you understand, use your notes, go back and look over the notes, do some extra problems. In our notes, there are plenty of extra practice problems that you can try, and then you check your answers. So I have the complete notes in Schoology. You need to make sure that you're practicing enough so that you feel good about this quiz. Okay, I can only change numbers for compound interest problems. All I can do are change some numbers around, but how we type it in, if you do one problem, you can do them all. Okay, so I'm hoping that students will be prepared for this quiz. And if you have any questions, please reach out to me. Okay, that took me 14 minutes to go over 12 problems. Okay, thanks for watching. Take care.